This video response is going to go out to Danica McKellar, and that's because I'm continuing my review of your book entitled Math Doesn't Suck. And this is what I've got to say about the next chapter in the book. This will be part 7 this time. Alrighty. Now, when you tell someone about an event, you can give a person basic details, or you can give them more specific details. For instance, you could tell someone that yesterday it rained outside. Oh, big deal. Or you could tell them you observed horizontal rain, or that you saw flash flooding. Now that makes the story a little more interesting. So how do you determine which details to give to the person you're talking to? Perhaps you want to add dramatic emphasis to the story because you think that the person you're talking to doesn't think that the situation you were in wasn't as serious as you observed it to be. On the other hand, you may want to give basic details to somebody because you've just met that person. Maybe you don't know this person at all. You just want to give them a, well, yeah, I was out there and it rained yesterday. Ooh, okay. Maybe you just met a person. Who knows? And it's true that two people won't state the same details about the same event. Perhaps one person is more observant than the other. Perhaps one person was more impacted by the event than the other one. Two people can witness flash flooding, but perhaps one person suffered flash flooding damage in their home, while the other one was just simply a weather observer. Two people reporting on the same event, but they have two different versions of the story because of the way it impacted them. See what I mean? Now, why is all this important? Because you can express things in many different ways, and you're giving the same basic details. I mean, when both people say, hey man, it was flooding, just because one person says, hey, it was flooding and it flooded my basement, while the other one just says, hey, I just saw flooding on the road, well, they're telling you that there was flooding. But you see, there's two different stories. So they're expressing the same event, but with different details. Okay. That happens all the time. You look at news reporting, you'll find that out. I agree that mixed fractions can have the same value as regular fractions. But let's look at the etymology of the word equivalent. I'm sorry, I'm kind of getting over a cold, so I'm going to try to do this the best I can. The word equivalent comes from the Latin word equus, which means equal or flat. Okay, and this is probably an old-time Latin agricultural term. They were trying to evaluate equal plots of land. See what I mean? Alright. Now, the ending of the word equivalent comes from the Latin word valere, which means something of value or of worth, okay? Because land at that time was worth something. You actually sold land. You bought land. See, it was worth something. There you go. I mean, when they tax your land, it's worth something. I can tell you that for sure. Alrighty. I wish schools would do a better job in teaching their students about proper nutrition, because I have actually learned through personal experience that eating apples assists with digestion. In other words, it's a natural laxative. That's what it is. And when more people realize this, no matter how tasty, whether you're talking about applesauce, you know, when I was a kid, well, actually a young adult, I used to go to Champaign, and they have this pumpkin patch, and they sell these apple cinnamon donuts, and they are good. They are really good, but they do have apple in them, so they do have somewhat of a digestive effect. So you don't want to eat too many of them. Eating one or two is great. You eat the whole box, you're going to be in trouble. Okay? So, that's something you might want to keep in mind whenever you're eating a product with apples in it. I mean, that's why they give them to young kids, to help with their digestion. That's how it works. Okay, I agree that you can express a numerical value in several different ways and maintain the value despite how you express the value. just look at the retail environment. You can say that you could buy a box of laundry detergent for $3. That means you could buy 2 boxes of laundry detergent for $6. Or you can say, hey, if you buy the first box of laundry detergent for $6, I'll give you a second box for free. Well, if you buy both boxes, you're paying $3 a piece for them. So the value of the boxes hasn't changed just because they express the value of them in 2 different ways. That's something you should look into in retail, because sometimes things are not what they seem to be. Gotta be a smart shopper these days. Alright, it is also true that if you divide a number by itself, you get the number 1. Let's take the number 6. If you divide 6 by 6, you'll get 1. Take any number like that. 12 divided by 12 is going to be 1. 2 divided by 2 is going to be 1. That's true. So, if you have 2 as the numerator and 2 as the denominator in a fraction, you divide 2 by 2, you're going to get 1. That's just a fact. Go ahead, check it out. You'll find out. Now, what if you wanted to add the number 1/2 by 1/4? Now, this is where I'm going to go ahead and get the dry erase board. I said reader board earlier. That was my mistake. So, let's say you want to add the 2 numbers. Now, for those of you who are on my live stream, when you watch the regular video, you'll be able to see this clearly. There it is, 1/2 by 1/4. Okay. Now, can you add this at this point? Nope. Why? Because you'd have problems adding this. Okay, so how do you add this up? Okay. So, what you're wanting to do is you're going to want to change that number to 4. How are you going to change that number to 4? Okay. You have to first figure out what number to multiply 2 with to obtain 4. Okay? Now, in this instance, the number 2 here, this number 2, is the multiplicand, and that's very important. Now you see the reason why we explore etymology. Okay? Because this is the multiplicand. I'm going to write it up here. Oops. That's the multiplicand. That number there is the multiplicand. And what you're going to multiply that number with to obtain 4 is going to be known as the multiplier. So, we're going to take the multiplicand and we're going to multiply it by a multiplier to obtain the product of 4. Okay? So, what value are we going to use for the multiplier? Well, 2 times 2 equals 4. Okay? So, 2 will not only be the multiplicand, but we're going to have another 2 over here called the multiplier. We're going to multiply the multiplicand by the multiplier to get the product. That's why you study Latin etymology. And when you learn this vocabulary, it will be much easier to express all this stuff. Okay, now we know that this multiplicand, when it was multiplied by the multiplier, became the product of 4. So we're going to take the multiplier, and now we're going to multiply this multiplier with this multiplicand. Now the number 1 becomes a multiplicand. The multiplicand times the multiplier becomes 2. So now you're going to have, instead of 1/2, let me get a rag here. Instead of 1/2, hope you can see that, the 1 becomes a multiplicand, the 2 becomes a multiplier, and multiplicand times the multiplier gives us the product of 2. So now we're going to change this fraction to 2/4. Now that the denominators in this fraction are the same, we can add up the numerators. Now we have 3/4. And that's how that works. Alright, so let's review. We took the denominator of the original fraction, turned it into a multiplicand, found a multiplier that would turn that multiplicand into the product of 4, and then took that multiplier and multiplied it by the multiplicand, which we turned the numerator of the fraction into a multiplicand, and we multiplied that and got the product of 2. And that's how that works. That's why we study etymology vocabulary. Okay, so once you get used to that, it's real easy to remember. Alright. Now, how are you going to remember the word multiplicand? Okay, let's imagine that we have a multi-use trash can. Okay, multi-use trash can. Multi-use trash can, multiplicand. That's how you're going to remember that. So, we're going to visualize that the word multiplicand is actually a multiplying trash can. Okay, and then the multiplier, let's say that we're going to take the multiplicand, which is the trash can, and we're going to multiply it by a pair of pliers. So your multiplier, let's say that the brand of let's say the brand of the trash can and the pliers is multi. Okay? Oh, we've got a multi-trash can. We've got a multi-pair of pliers. There you go. And that's all you need. So, the first number in the multiplication problem is the trash can. The second number in the multiplication problem is the pair of pliers. And that's how you remember that. Try that next time. Okay. Alright. Now, you also covered reducing fractions, and you went to greatest common fraction and least common whatever it is. And I'm not going to go into that. But whether you express a fraction as a regular fraction or a mixed fraction, as long as the value isn't changed, it's an equivalent fraction. Okay? And I'll show you what I mean by that. You can actually reduce a fraction So, the fraction 9/4 is the same as 2 1/4. Their values are exactly the same, even though you're expressing it a little bit different. Okay? And yes, you cover reducing fractions and you use the greatest common multiplier, or the greatest common whatever. I'm not going to go into it. Greatest common factor, whatever. That's all covered in commensurable numbers in Euclid Book 10. You can go look that up for yourself. But I think that's a much better way to remember things because it makes you sound more sophisticated. It makes you sound intelligent. And when you sound intelligent, they're more likely to hire you. Alright, so if you want to leave a response to any of this, you are more than welcome to do so. I will tell you more in a future video, so I'd like for you to stay tuned.